It is Teacher Tony. Let's talk about Loci and Loci of Inequalities. So when you talk about Loci and Loci of Inequalities, in the first case, you need to understand what we call a point. That is number one. When you are asked to find the locus of a point given a certain distance, maybe for example, find the locus of a point M, find the locus of all points that are equidistant from a certain point M, that is 4 meters, 4 centimeters, 4 millimeters away from the point. So you stand at that point, put your pair of compass at that point, and then make a circle. So you learn that when you're asked to find the locus of a point, what you're expected to draw is a circle. A circle is expected. Number two, when you are asked to draw the locus of 2 points, that is a line. So for example, you have got a point A and B. When you join point A and B, you form what we call a line. So when you are asked to find the locus of all points that are equidistant from point A and B, what you are expected to draw is you draw a perpendicular bisector. A perpendicular bisector. So for example, draw the locus of all points that are equidistant from point A and B. Stand at point A with your pair of compass, make an arc. At point B, make an arc. And then stand at this point to make an arc, this point to make an arc, and then you draw a straight line. So maybe point O is the midpoint of A and B. So when you are asked to find the locus of all points that are equidistant from when you are given 2 points, that's A and B, what you are expected to draw is a perpendicular bisector. Number 3, when you are trying to ask the locus of 3 points, this is the same as the locus of two lines that share a common point. So for example, you have got line A, B, and line B, C. So this is the locus of 2 points that share a common point, that is point B. So for example, you have got a line, maybe a triangle, for example, this is A, B, C. So if you take line A, B, and B, C, what you realize that is they share a common point, that is point B. So what you are expected to have here is what we call angle bisector. So when you are asked to find the locus of all points that are equidistant from point line A, B, and B, C, what you are expected to do here, you divide this angle into 2. That's what we call angle bisector. So for example, we start at this point to make an arc, start at this point to make an arc, this point to make an arc. At the end of the day, you will have divided this angle into 2 equal parts because of the property that we call angle bisector. So another point we want to look at loci of inequalities. How do we present information on graphs using the concept of loci of inequalities? So number one, in loci of inequalities, we have got several signs that we're going to use. We can use a sign like less than. We can use a sign like greater than. You can use a sign like less than or equal to. You can use a sign like greater than or equal to. So when you have been given less than sign, what are we expected to draw in your graph? When you're given this sign, there is something we call the nature of the line. Nature of the line. When you are given these signs, so for example, you have been given less than sign. What is the nature of the line? So we think we are expected to have a broken line. When you are given a greater than sign, when you present your information on a graph, we have a broken sign also, a broken line also. When you have got less than or equal to, we have a complete line. When you have got greater than or equal to, we have got a complete line also. So what we are supposed to know that when you have got less than or equal to sign, for example, y is less than or equal to 2. What we are expected to know that y can be either 2, it can be either 1, it can be either 0, and etc. So when you see less than or equal to, and you have been given a certain number, whereby you have got a certain identity y, that means that 2 is also inclusive as well. So when you have got also greater than, maybe x is greater than or equal to 2. So that is what we mean here. X can be either 2, it can be either 3, it can be either 4, and etc. So when you are given this sign, the less than sign, for example, x is less than 3. What we realize here, 3 is not inclusive in x function. So you cannot say x equal to 3 when you are referring to this function. It will be wrong. But you can say x is equal to 2, it can be 1, it can be 0, and etc. Another final thing, when you've been given x is greater than 3, that what we learn here, x is not inclusive as the possible value of x. So x can be either 4, it can be 5, it can be 6, it can be 7, and etc. So that's what we are expected to do. That's the concept that we are expected to learn, as well as loci and loci of inequalities are concerned. Thank you for watching. Remember to subscribe to my YouTube channel, like, comment, and subscribe for more.